Hello, and welcome. Today we're traveling back to the origins of one of nature's most fascinating creatures, snakes. But these aren't the snakes we know today. We're meeting their earliest ancestors. These ancient serpents are living fossils, holding clues to how snakes lost their legs, developed unique hunting methods, and diversified into thousands of species. Their remains, found in ancient rocks, reveal a world that was warmer, lusher, and teeming with life. Let's begin our journey into this lost world and meet the oldest snakes that once ruled the earth. Our journey begins deep in time, in the Paleocene epoch, an era that dawned 10 million years after the cataclysmic extinction that wiped out the dinosaurs. The world was healing and life was surging back in new and unexpected forms. Imagine a planet blanketed in dense, steaming rainforests, where the air was thick with humidity, and the sounds of strange, ancient creatures echoed through the trees. In the heart of what is now Colombia, a true giant slithered through these primeval jungles, Titanoboa ceratogenensis. This was no ordinary snake. Titanoboa was the largest serpent ever to have lived, a creature so massive and powerful that it has become the stuff of legend among paleontologists and snake enthusiasts alike. Stretching an astonishing 42 feet from head to tail and weighing in at over 2,500 pounds, Titanoboa dwarfed even the largest snakes alive today. To put that in perspective, it was longer than a city bus and heavier than a grand piano. Even the mighty green anaconda, the largest living snake, would look small beside this prehistoric behemoth. The first clues to Titanoboa's existence came from the Cerrejón coal mine, where paleontologists unearthed enormous fossilized vertebrae. These bones were so large that at first, scientists could hardly believe they belonged to a snake. The discovery sent shockwaves through the scientific community, forcing researchers to rethink what was possible in the world after the dinosaurs. As an apex predator, Titanoboa ruled its swampy domain. It likely hunted giant turtles with shells as thick as armor, and primitive crocodiles that lurked in the murky waters. Nothing in its environment was safe from its crushing embrace. Much like today's anacondas, Titanoboa was a master of stealth. It spent much of its life in the water, gliding silently beneath the surface, waiting patiently for the perfect moment to strike. Its immense size allowed it to ambush even the largest prey, using the element of surprise to its advantage. When Titanoboa attacked, it did so with overwhelming force. Wrapping its muscular coils around its victim, it squeezed with enough pressure to shatter bones and stop the flow of blood in seconds. This method of constriction was both brutal and efficient, ensuring that few animals could escape its deadly grip. After a successful hunt, Titanoboa would swallow its prey whole, sometimes creatures as large as a modern cow. Its flexible jaws and expandable body allowed it to consume meals that would sustain it for weeks or even months before it needed to hunt again. But how did such a colossal snake come to exist? The answer lies in the Paleocene's climate. With average temperatures soaring around 90 degrees Fahrenheit, the world was a greenhouse, and the warm, humid air allowed cold-blooded reptiles like Titanoboa to grow to unprecedented sizes. The lush rainforest provided both the food and the environment needed for such giants to thrive. The unearthing of Titanoboa's fossils was more than just a scientific milestone. It was a window into a forgotten world. It proved that life rebounded with astonishing speed and creativity after the dinosaurs vanished, filling the void with new giants and new wonders. The age of reptiles didn't simply end with the last dinosaur, instead it transformed, giving rise to new forms like Titanoboa that would dominate their ecosystems for millions of years. Evolution found a way, and the reign of the reptiles continued in unexpected ways. Today, Titanoboa stands as a symbol of prehistoric power and adaptability, a reminder of the extraordinary creatures that once ruled our planet. Its story is a testament to the resilience of life and to the mysteries that still lie buried beneath our feet. For millions of years, Titanoboa was the undisputed monarch of its swampy kingdom, gliding silently through the ancient wetlands, feared by all who shared its domain. Its existence is a powerful example of how life on Earth can adapt, survive, and even flourish after catastrophe. The rise of Titanoboa shows us that even in the wake of mass extinction, nature's creativity knows no bounds. And as we venture further into the ancient world of snakes, Titanoboa is just the beginning. countless other serpentine giants and mysterious reptiles await discovery, each with their own incredible story to tell. Now, we travel further back in time, deep into the mysterious and ancient world of the Jurassic period, a time when the Earth was ruled by giants, and the land was cloaked in thick, misty forests teeming with life both familiar and strange. Our journey takes us to a quiet corner of England, to the Kirtlington Quarry in Oxfordshire. Today it may look like just another patch of countryside, but beneath its surface lies a window into a lost world. It was here, among layers of ancient rock and sediment, that scientists made a remarkable discovery: the fossilized remains of Eophis underwoodi, one of the oldest known snakes ever found. Eophis, whose name means dawn snake, lived an astonishing 167 million years ago. Its existence pushes the origins of snakes far back into the age of dinosaurs, revealing that these creatures have been slithering through the shadows since the very dawn of reptilian history. The fossils of Eophis are incredibly small, tiny vertebrae, each one smaller than a pinhead. These delicate bones suggest that Eophis itself was a miniature snake, likely measuring less than 10 inches from head to tail. Imagine this tiny reptile weaving its way through the thick leaf litter of the Jurassic forest floor, hunting for insects and worms. While massive dinosaurs thundered above, Eophis survived by staying hidden, moving silently and swiftly through the undergrowth, a master of stealth in a world of giants. Its anatomy is a fascinating blend of old and new. Eophis retains primitive features that link it to its lizard-like ancestors, suggesting that the earliest snakes may have evolved from burrowing or even aquatic lizards, gradually losing their limbs as they adapted to new ways of life. The small size and secretive lifestyle of Eophis support the idea that snakes first evolved as burrowers, perfectly suited for life underground. Just like some modern snakes, Eophis may have spent much of its time hidden beneath the soil, safe from predators and able to exploit a world of tiny prey. Picture Eophis moving quietly beneath the forest floor, while the colossal feet of dinosaurs passed overhead, completely unaware of the tiny pioneer beneath them. This hidden world was full of creatures that rarely saw the light of day, yet played a crucial role in the ecosystem. The discovery of Eophis in Europe suggests that this continent may have been a cradle for early snake evolution. It's a reminder that even in places we think we know well, there are still secrets from the deep past waiting to be uncovered. Unlike the gigantic Titanoboa that would appear millions of years later, Eophis doesn't impress with its size. Instead, it fascinates us with its ancient origins and the story it tells about the humble beginnings of snakes. By studying the fragile bones of Eophis under the microscope, scientists are able to piece together the early chapters of snake evolution. Each tiny vertebra is a clue, helping us understand how a group of small, secretive animals would one day spread across the globe and diversify into the incredible variety of snakes we see today. Eophis is a crucial piece of the evolutionary puzzle. Its discovery helps fill in the gaps, showing us how snakes began their long journey from small, hidden burrowers to the remarkable and sometimes fearsome creatures that now inhabit every continent except Antarctica. Long before the age of giant serpents and legendary predators, there were small, secretive trailblazers like Eophis, quietly shaping the future of life on Earth, one tiny slither at a time. Our journey continues in Jurassic Poland, a land that looked very different from today. Here in the heart of what was once a lush, subtropical landscape, paleontologists made a remarkable discovery: the fossilized remains of an ancient snake known as Diabel camele, or the devil from Camilo. This evocative name hints at the creature's mysterious presence, buried for millions of years beneath layers of clay and sediment. Diabel camele lived around the same time as Eophis, another early snake, but it was a very different animal. Measuring about 3 feet in length, Diabel was noticeably larger and more robust than its English cousin. Its size alone would have made it a formidable presence among the small vertebrates and amphibians that shared its swampy home. Imagine this ancient serpent gliding silently through dense ferns and tangled roots, its scales glistening in the filtered sunlight of a primeval forest. The fossilized jawbone of Diabel camele is a window into evolution in action. When scientists examined its structure, they found a fascinating blend of features, some reminiscent of lizards, others pointing toward the modern snakes we know today. This jawbone, with its unique shape and articulation, shows us a crucial stage in the transition from lizard-like ancestors to the flexible, highly specialized jaws of modern snakes. Unlike today's snakes, Diabel hadn't yet evolved the hyper-flexible skull that allows modern serpents to swallow prey much larger than their heads. However, its teeth were already sharp, recurved, and perfectly adapted for gripping and holding on to struggling prey. These teeth suggest that Diabel was an effective predator, able to seize small animals and prevent them from escaping its jaws. In its swampy, river-crossed habitat, Diabel cameel likely hunted a variety of small vertebrates, perhaps amphibians, early mammals, or even juvenile reptiles. It was a mid-tier predator, not the top of the food chain, but certainly a threat to many of the creatures that shared its world. The Jurassic landscape was teeming with life, and Diabel played a vital role in this ancient ecosystem, helping to keep populations of smaller animals in check. The name Devil doesn't refer to any sinister behavior, but rather to the surprise and excitement its discovery brought to the scientific community. Finding such a well-preserved and unusual snake fossil in Poland was unexpected, and it challenged previous ideas about where and how early snakes evolved. The discovery of Diabel cameel, alongside Eophis from England, reveals that early snakes were already diversifying in both size and form across the supercontinent of Laurasia. These finds suggest that snakes were not only widespread, but also experimenting with different lifestyles and ecological roles much earlier than once thought. Some of these early snakes were tiny, secretive creatures, hiding among leaf litter and roots. Others, like Diabel, were more active hunters, using their size and strength to pursue prey. This variety in body size and behavior is a hallmark of evolutionary success, allowing snakes to adapt to a wide range of environments and challenges. The early diversity seen in snakes like Diabel cameel marks them as one of the most successful evolutionary groups from the very beginning. Their ability to adapt, experiment, and thrive in different habitats set the stage for the incredible variety of snakes we see today. Thanks to modern technology, scientists can now use high-resolution CT scans and digital modeling to study the intricate details of Diabel's skull and feeding mechanics. These tools allow researchers to reconstruct how this ancient snake moved, hunted, and interacted with its environment, bringing the distant past to life in vivid detail. Each new fossil discovery, like that of Diabel cameel, adds another piece to the puzzle of snake evolution. Every bone, tooth, and scale helps scientists understand how snakes gradually transformed from their lizard-like ancestors into the specialized, limbless predators we know today. The Jurassic world was not just the age of dinosaurs, it was also a time of subtle, creeping innovation, when creatures like Diabel cameel were quietly pioneering new ways of life, experimenting with body shapes and hunting strategies that would one day lead to the incredible diversity of snakes. Diabel cameel stands out as one of the early successes in this evolutionary experiment, a true pioneer of the serpentine form, adapting to a world dominated by giants and finding its own unique niche. The fossils of Diabel cameel help us understand how snakes experimented with new body plans and survival strategies in a world filled with towering dinosaurs and strange ancient plants. Each discovery brings us closer to unraveling the story of how snakes became one of the most fascinating and adaptable groups of animals on Earth. Our final stop is a coal mine in Portugal, where Portugalophus lignites was discovered. This late Jurassic snake, about 3 to 4 feet long, is known from a beautifully preserved jawbone. Portugalophus shows a more advanced stage of snake evolution, with teeth set in shallow sockets, a key snake trait. Its sharp, backward-curving teeth were ideal for catching and holding prey. Living in a coastal, swampy environment, Portugalophus hunted among crocodiles, turtles, and small dinosaurs. Its existence confirms that the snake body plan was already successful across Europe. Comparing Eophis, Diabel, and Portugalophus reveals the gradual development of snake-like features. These fossils argue that snakes evolved on land, not in the sea. The preservation of Portugalophus in coal swamps is a rare stroke of luck, allowing us to study its delicate bones. By the late Jurassic, snakes were already efficient specialized predators. Portugalophus bridges the gap between primitive forms and the diverse snakes that would follow. Its story is a testament to slow, steady evolutionary change. Together, these ancient snakes illuminate the deep roots of one of Earth's most successful animal groups. Our journey through deep time reveals that the story of snakes is far older and richer than we imagined. From tiny Eophis to the colossal Titanoboa, these fossils show evolution in action, how lizards became legless wonders. Each discovery is a new chapter, reshaping our understanding of life's history. If you enjoyed this journey, Subscribe for more explorations into natural history's wonders. By looking back at these ancient serpents, we gain a deeper appreciation for the winding path of evolution. Until next time, stay curious.